Hey, welcome back to lesson 29, lenses. This lesson is really just a continuation of the last two lessons dealing with refraction and prisms, and we'll also see how they're linked very closely to mirrors, in particular curved mirror surfaces. Now before we begin, I'd like to give you a quick case study. Bubbles. We can see here that he is using lenses, of course, in the corrective means of glasses, and they have an interesting effect on his eyes, of course. We can see that they've actually made his eyes look much larger. Like curved mirrors, lenses will have a tendency to make objects appear either smaller or larger depending on their location from the surface. The difference, of course, is that light actually passes through lenses, where in mirrors, light bounces off. Let's just jump back to the notes. Now, lenses come in two flavors: converging and diverging lenses. Converging lenses are those that are convex shaped, so they kind of curve out in the middle, being thicker or fatter in the middle. And diverging lenses are concave, meaning that they're kind of thinner in the middle, thicker on the edges. There's some examples down here below, but really we focus on just the double concave and the double convex lenses. We're going to just jump to an applet and see how these two different types of lenses work. Now before we begin, there are three key locations on a lens that should be mentioned. First, we have the dot here in the middle of the lens, which is often referred as the center or optical center. Here we have the focal point, or F, and this is where often before we would call it the center, but because we're calling this the center, this is often referred to as the 2F, so twice the focal. So we have 2F, F, O, or C, and then we have F and 2F again. If we grab the object, drag it kind of over here, you'll notice that as we get really far away from the 2F location, we get an image on the other side of the lens that's smaller and inverted. As we approach the 2F spot, you'll notice that the image becomes, like at the center in mirrors, the exact same size, but upside down. As we go from 2F to F, the object gets much larger until it disappears, and then pow! At this point here, as you might guess, we actually get no image. Then as we go to the other side, between the F and the center, you get an enlarged image, but it's on the same side. That's actually a virtual image. So if we quickly compare this to what we've done in the past, so this would be like a concave mirror, grab the object, you can see when we're really far back here, really far away from the center, or what on a lens is a 2F, it's upside down, small, get to the second dot here, same size, upside down, gets much larger up to the focal point, then nothing, and then we get a larger image, virtual. Quick review, same thing. Really far away, upside down, small, upside down, same size, upside down, really large, nothing, and then the larger virtual image. Bubbles. Actually, that brings up a good question. What kind of lenses do you think Bubbles has? Take your guess, let me know later. Now this wraps up convex lenses, so it of course leads to the next type of lenses, which is concave lenses. So of course, same idea, optical center, F and 2F. When we drag the object far away from the 2F or center point of like on a mirror, we can see the image is smaller and right side up, and it always actually stays smaller and right side up. Sounds very familiar to something else that we've looked at. Looking back at convex mirrors, we can see the exact same thing. Regardless of how far back we pull the object, the image is always right side up and smaller. As we approach the mirror, object gets bigger, but still always stays smaller than the original object and right side up. Let's jump back to the notes now and take a look at some of the material that we've been talking about here. Now, like mirrors, it's often easy to see the image that's produced by drawing a diagram. Often you can trace the diagram by looking at three key lines, the PCF, or a line parallel, a line through the optical center, and a line going through the focal point. We can see here a line going through the focal point will hit the lens and then go straight. A line going parallel will hit the lens and then refract going through the focal point. And a line going through the center is going to keep traveling in a perfectly straight line. What you should have is three lines starting from the object reforming together at the image. While the diagram can help, it's always useful to also memorize the simple rule with regards to the 2F, F, and then optical center location. That being that the object is always, of course, smaller in front of the 2F, larger between the 2F and F, and then larger between the F and the optical center, but of course a virtual image right side up. When drawing diagrams for diverging lenses, you only have to draw two lines. A line drawn parallel will refract upwards away from the first focal point. So you draw a dotted line back towards the focal line, and then a line drawn through the optical center will of course travel in a straight line. Where those two lines cross, we can see here that's where the image would be produced. Now the last thing we need to talk about is the relationship between converging and diverging lenses and the formula. You can see here that the formula is exactly the same as the one for mirrors, and there's a direct relationship between negative and positive signs. Positive signs are for real objects and negatives are for virtual objects, exactly the same as mirrors. As well, the focal point is positive for converging lenses and negative for diverging lenses, which is actually the same for converging and diverging mirrors. Now, because the formula is exactly the same as the one that you've used for mirrors, I suggest that all you do is use the practice sheets that I've given you and go over some of the examples just to make sure that you can do it with lenses just like you could for mirrors. Once you've done that, really, I'd just go to the internet and look at some funny glasses. We'll see you in lesson 30 next week.